Now my dear students, we can go to the question number 36. Here 36, a solution of urea, molar mass 56 gram per mole boils at 100.18 degrees Celsius at the atmospheric pressure. If Kf and Kb for water are 1.86 and 0.512 Kelvin kilogram per mole respectively, the above solution will freeze at. Here this question is also asked in 2005. My dear students, I give you formulas and you can put the values of formulas and you can get the answer. Number 1, we have formula delta Tf is equal to Kf into small m. Another we have formula delta Tb for boiling point, that equal to Kb into small m. Now my dear students, when we can divide it 1 and 2 equation, then we can get the delta Tf upon delta Tb, that equal to Kf into small m upon Kb into small m. So you can get the Kf upon Kb, delta Tf is equal to Tb upon Tb, that equal to Kf upon Kb. You can get in this type of formula. Now my dear students, we get the formula delta Tf, and this is the relationship between 2 delta Tf upon delta Tb, that equal to Kf upon Kb. My dear students, you can learn this formula. In this formula now we can see what is the values of these, and this question what is asking. Now we can see here delta Tf. What is the delta Tf, my dear students? Here he asking the fridges respectively above solution will fridges, means first of all you can calculate the delta Tf. Now here he give us delta Tb. Where is delta Tb? A solution of urea boils at 100.18 degrees Celsius. Urea solution is boiled 100.1 degrees Celsius, means it's 100 degrees Celsius for boiling point of solvent, and solution is boiled 100.18 and 100 degrees Celsius is a boiling point of water. So my dear students, this boiling point of water is when you can subtract, then boiling point of solution, this is the boiling point of solution. So my dear students, you can get the delta Tb is equal to 0.18 degrees Celsius. Now my dear students, you can get the 0.18 degrees Celsius delta Tb. Now we can here see the what is the Kf. Kf is the freezing point constant, and my dear students, freezing point constant here you can see Kf is 1.86. What is the Kb? Here you can see Kb is the numerical 0.512 Kelvin. So Kb is there, Kf is there 1.86, Kb is there, and Tb we can find out the delta Tb, and now we can first of all find out the delta Tf, then we can find out the solution of freezing point. So put the values here, delta Tf upon delta Tb is 0.18, that equal to Kf is 1.86 upon 0.512. My dear students, when you solve this, delta Tf is equal to 1.86 multiply by this 0.18 upon this is 0.512. You can solve this equation, you can solve this point, you can solve this equation, and the point is replaced by 0, all points are replaced by 0, and 512 is divided by 186 and 18. Then my dear students, you can get the values of delta Tf, that is 0.654. Now we can see the what is the value of freezing point of solution, that is 0 minus 0.654. So you can get the answer minus 0.654 degrees Celsius. Now my dear students, you can see the answer, that is minus 0.654, and this answer is present in B option. So my dear students, this type of questions you can solve in this way. First of all, you can use your old formulas which are given in your topic, delta TF and delta TB. Now we can correlate ratio, because in this question KF and KB are also given. So you can put this formula and get this new formula. Put the values and get the answer. So my dear students, I hope you understood and you get new formulas and you solve this type of problems. Now my dear students, we can go to the question number 37. Here a solution contains non-volatile solute of molecular mass M2. Which of the following can be used to calculate the molecular mass of solute in terms of osmotic pressure? My dear students, I am already told you pi is equal to N RT upon volume. And when this N is placed in M upon B, then this is W RT upon MB. So my dear students, you can see here this pi is equal to WRT upon MB. Here W or M2, you can see here W or M2. And my dear students, this N is also called, that is moles, and you can also see here moles upon volume. When you can take the moles, this whole M2 upon volume into RT, you can see here. Now my dear students, when you can see the mass, then mass of solute, here W is taken as a mass of solute, here is the M2, V is taken as a volume, and then you can calculate the mass. M, small m is equal to M2 RT upon pi into V, and this is the formula which are used in osmotic pressure. So you can go the answer B. Question number 37 asked in 2002. Now my dear students, we can see here question number 38. Pure water can be obtained from seawater. Pure water can be obtained from seawater. What is the theory behind it? This question. You can see that in seawater, electrolytes are present. Electrolytes are present. So my dear students, electrolytes and impurities are present. So my dear students, when the seawater is converted to pure water, we can use the reverse osmosis. What is the reverse osmosis, my dear students? In reverse osmosis, we can see here, this is the SPM, semi-permeable membrane, and here this is the concentrated solution. That it is a seawater in which NaCl, sodium chloride, MgCl2, Na2SO4, these electrolytes are present. So my dear students, when we can increase the pressure, in this side, this is a piston, and we can increase the pressure in this side. So seawater, when pressure is increases, then seawater in which water concentration is low but go through this SPM. So my dear students, water is go through this SPM and you can get the pure water. And this type of osmosis is called reverse osmosis, and this reverse osmosis is present in purification of seawater, reverse osmosis. So my dear students, this reverse osmosis you can see here, and in this question number 38, answer is C. Now my dear students, we can see the question number 39, and this question is also asked in NEET 2000. From the colligative property of solution, which one is the best method for the determination of molecular weight of proteins and polymers? Here molecular weight of proteins. My dear students, proteins are the high molecular weight compounds. High molecular weight compounds, and when we can determine the high molecular weight compounds molecular weight, then easy and good method, it is called osmotic pressure. We can use the osmotic pressure, and this is a easy method, and high molecular weight compounds are easily determined by this method. And you can see the formula here, pi is equal to WST upon MB. We can use this formula to determination of molecular weight. M is equal to WST upon pi V. So, my dear students, you can easily use and determine this molecular weight. So, 5-minute rest. Question number now, my dear students, question number 40. The vapor pressure of benzene at a certain temperature is 640 millimeter of mercury. A non-volatile and non-electrolyte solid weighing 2.175 gram is added to 39 gram of benzene. The vapor pressure of the solution is 600 millimeter of mercury. What is the molecular weight of solid substances? Now, here, my dear students, we can use the vapor pressure formula, Raoult's law formula, Raoult's first law, and what is that formula? My dear students, that formula is a P0 minus Ps upon P0, and that equal to, my dear students, small w upon capital M upon capital W into small m. Here, my dear students, what is the small w? Small w, that equal to weight of solute in grams. What is the capital M? That is the molecular weight of solvent or water. Generally, we can take the water or solvent. Here, you can water or you can take the solvent, molecular weight of solvent. If water is not taken, then solvent. And here, what is the capital W? This is the weight of solvent, and capital W and small m. What is the small m, my dear friends? Small m is the molecular mass of solute. So, in this way, we can see here what is the P0? P0 is the vapor pressure of pure solvent, and what is the PS? That is the vapor pressure of solution. Now, we can here put the values. P0, vapor pressure of pure solvent. Here you can see the vapor pressure of solution is 600 and vapor pressure of benzene at 640. So, you can put here 640 minus PS, vapor pressure of solution is 600, put the values 640 small w, weight of solute. Here you can see the 2.175 gram is added to 39 gram of benzene. So, small w is the 2.175, it is small w, and capital M, molecular weight of benzene. Now, here we can calculate the molecular weight of benzene. Capital W 39.8 gram. Here it is given, and small m, you can calculate the small m. Now, my dear friends, when small m is calculated, what is the molecular mass of benzene? Carbon 12 multiplied by 6, that is equal to 72 plus this 6, and you can get the 78, and 78 the molar mass of this benzene. Now, my dear students, it is a values, we can put the formulas, and after this putting the value, you can solve the molecular weight of this M. And my dear students, when you can put the M, what is the M? M that equal to, when 640 minus 600, you can get the 40. So, 2.175 into 78 into 640, and that is divided by 640 minus 600, that is 40, multiply by this 39.08. My dear students, when you can solve this problem, point is replaced, 0, point is replaced, multiplication and divide. When you can done this multiplication divide, then molecular mass of this solid substance, you can get, my dear students, 69.5, and this is the answer of your question. Now, you can go to the question number 40, you can go to the answer A. Here, my dear students, when we go to the question number 41, this question is also asked in 1999. Here we can see a 0.15 gram of solute dissolved in 15 gram of solvent is boiled at temperature, means he used the elevation of boiling point higher by 0.216 degree than the pure solvent, the molecular weight of the substance he wanted. Molar elevation constant is given. So, my dear students, what is the formula which are used? Our formula is delta Tv is equal to Kv into small m. And what is this small m? It is a multiply by Kv into small m is molality. You can know very well, W into 1000 upon small m into capital W. Now, we can put the values, my dear students, and you can calculate delta Tb. Your value is Kv, we can put the values. Kv is given in numerical 2.16, small w given in numerical 0.15 into 1000 upon small m is also given in numerical molecular weight of substance. No, not it. It is not given in numerical, means it is calculated. Okay. What is the capital W? It is given in numerical, capital W weight of, yes, 15. 0.15 dissolved in 15. It means delta Tb is already given in the numerical, yes. Elevation of boiling point, it is given, that is 0.216. You can see here, that is 0.216. Delta Tb is the 0.216. You can put, and you can get the small m here. This 2.16 multiply by the 0.15 multiply by the 1000 upon 0.216. So, your calculation is very easy, because in this calculation, this question is as in 1999 NEET exam. In this calculation, point is replaced by 30, you can put here. Now, this point is replaced, you can put here 20. This point is replaced, you can put here 20. 1, 2, 3, 4. 4 point you cancelled out, 1, 2, 3, 4. And you can get this 216 are cancelled, 15 cancelled. Means, my dear students, you can get the 100 gram. And this is the question number 41, you get 100 gram. B. Because, my dear students, this is a very large question, and when you can put the values and calculation is very easy, this calculation is easy, you can cut and get the answer. So, my dear friends, question number 41, you can get the answer B. Now, we can see here question number 42. Here question number 42, a 5% solution of cane sugar, molecular weight is equal to 342 is isotonic with 1% solution of a substance X, the molecular weight of X. Here I gave you a formula of isotonic solution before, my dear friends, before the questions. Here in isotonic solution, I know very well, we know very well, osmotic pressure is same, concentration is same. Here W1 upon M1 is equal to W2 upon M2. Here 100 concentration same, volume same, here both the volume is 100. So, no problem at all. Here 5, you can put here 5 or you can put in 50, no problem. Then you can put here 10. So, when you can put here 50 upon 342 upon 10 upon small m2, you can calculate it, my dear students. M2 is equal to 342 into 10 and here this 50. Then, my dear students, you can calculate the 342 upon 5. This is go to 6, you can cancel 6 and you can get here 68, okay, 0.4 because 342 divided by 5, okay, 42, 68.4. Now you can go the answer A, 68.4. This is the correct answer. We can use this formula, my dear students, because isotonic solution, when isotonic solution is given in numerical, then my dear students you can use this formula. Here, because the isotonic solution concentrations are same, C1 is equal to C2, V1 is equal to V2. Here in percentage are given, so it is not necessary to, you can convert into liter. We can put here 5 upon 342, that equal to 1 upon M2. Then my dear students, you can also get the 342 upon 5 means 68.4. It is not necessary because here percentage 1% here and 5% here. Here volume is same. So volumes are cancelled with each other. Volume is same. If volume is not same, my dear students, then you convert the volume is same. Here if you get the 100,000 liter, 1000 milliliter, and here you can get the 5%, then it is converted to 1000 milliliter. This is the way. So my dear students, you can get the answer 42, answer is B. Now we can go to the question number 43. Here my dear students, in question number 43, the vapor pressure of solvent decreased by 10 millimeter of mercury. Vapor pressure of solvent is decreases 10 millimeter mercury, okay, when a non-volatile solute added to the solvent. The mole fraction of the solute in the solution is 0.2. What should be the mole fraction of the solvent if the decreases in the vapor pressure is to be 20 millimeter of mercury? My dear students, we can use the formula, and this question is a somewhat lengthy question. Here we can see here P0 minus Ps upon P0, that equal to mole fraction, X2 is a mole fraction, and here you can see the P0 minus Ps, that is equal to 10. Here you can see the vapor pressure of solvent decreased by 10 means P0 minus Ps, that equal to 10 upon P0, and that equal to X2. My dear students, X2 is the mole fraction, and here in this question mole fraction is already given by you, that equal to 0.2. Then my dear students, you can solve the P0, that equal to 10 into 0.2 means 2, 0.2 you can solve. P0 is equal to 0.2 multiplied by 2. My dear students, you can get the 2 millimeter mercury. Now we can see here this again, this is a number 1, number 2, again this vapor pressure decreases by 20 millimeter mercury of mercury. Then my dear students, P0 minus Ps upon P0, that equal to mole fraction of solute means 20 upon, and here you can get the P0, that equal to 2 is equal to mole fraction of solute, that is X2, and you can get the X2 mole fraction of solute. You can divide it, and that equal to 10 mole fraction of solute. My dear students, here you can get this, that equal to 50, or because you can get the 50 millimeter mercury, so you can put here 50, and when you can put here 50, then my dear students, you can see this 20 upon 50, that equal to 4, and when you can get this 4.4 millimeter mercury, this is the mole fraction of X2 solute. Here mole fraction of solvent 1 minus, here we can see formula, that is third formula, x1 plus x2, that equal to 1, and x1 is equal to 1 minus x2. So, you can get the 1 minus 0.4, you can get the 0.6 and you can go to the 0.6 in this question. Now, my dear students, we can go to the question number 44. The vapor pressure of CCl4 at 25 degrees Celsius is 143 millimeter mercury. If 0.5 gram of non-volatile solute is dissolved in 100 gram CCl4, the vapor pressure of the solution will be. Now, we can use the formulas here. Here we can use the P0 minus Ps upon P0, same formula is used, and that equal to mole fraction means small w upon capital M upon capital W into small m. Now, here we can see that what is the P0. You can see the vapor pressure of CCl4 is 143 millimeter mercury. It's a P0 in millimeter mercury. What is the Ps? Vapor pressure of the solution you must be calculated here. What is the small w? 0.5 gram. What is the capital W? It is 100 gram. What is the small m? It is a 65. And what is the capital W? It is also a 100 gram. Capital W is 100 gram. So, my dear students, you can put these values and get the answer. We can put the values here. P0 143 minus Ps upon P0 143, that equal to small w 0.5 multiply by the capital M. Here capital M, molecular weight of water. Here CCl4 non-volatile solute is 65 and capital M CCl4. Here, my dear students, we can see here the capital M. Capital M you can calculate it. 12 multiply by 35.5 multiply by the 4. So, you can get the 65. 65 is the capital M is a 65, but here 35 multiply by 4 it is not 65. Here that equal to 154. So, you can put here 154 upon capital W, here 100 multiply by the small m, that is 65. Now, you can calculate the Ps values. Here we can see the Ps is equal to 141.31 millimeter mercury. You can solve, you can multiply and divide and get the answer Ps, and you can get the answer C. Question number 44, answer is C. Now, my dear students, we can go to the question number 45. Here osmotic pressure is the, what is the concept of this question, my dear students? This question is also asked in 1996 NEET exam. Here concept of this question is that osmotic pressure is the colligative property. And osmotic pressure is the inversely proportional to molecular weight or molecular mass. When concentration is same, here you can see the osmotic pressure order. Glucose C6H12O6 glucose, you can get the molecular mass that equal to 180. Your second is urea, and what is the urea formula? My dear students, urea is the NH2CuNH2. Urea is the NH2 CuNH2. So, formula molecular mass is 60. Now, we can see here sucrose. In sucrose, C12 H22O11. C12 H22O11. Then you can get the 342 molecular mass. Here you can see this is glucose is a P1. Here urea is a P2. Here it is a P3. Now, my dear students, here you can see molecular mass is lower in urea. So, when molecular mass is lower, then osmotic pressure is higher, because osmotic pressure is colligative property and it is inversely proportional to molar mass. The concept and formula, when you use concept and formula of this, and you can get the answer. Now, you can get P1 because 180, then P3 342. In this way you can solve in this type of questions. Now my dear students, in this chapter in crash course, I gave you all the previous year questions which are asked in NEET exams 40 years and gave in each and every question concept and formulas which are used and solved, fully solved with the multiplication, and you give the answers. Now my dear students, I hope in your coming exam you can solve all the questions. Thank you.